In this video, I will be talking about closures in JavaScript. And the things that I will be covering in this video are listed in Contents Overview. So let's start this video with an analogy to understand closures. Imagine you have a secret clubhouse that only you and your friends can access. Inside the clubhouse, you have a bunch of toys and games that you all share. Even if you leave the clubhouse, the toys and games are still there for you and your friends to use whenever you come back. That's kind of like a closure in JavaScript. A function that remembers the variables it had access to, even after it's done running. You might not understand it now, but just keep these lines in mind. You will get clearer picture later. Now that, if you have ever encountered a situation in JavaScript where a function seems to remember variables from its outer scope, even after that scope is gone, that's closures behind it. So, what is a closure? In JavaScript, a closure is a special concept which can be seen in play when a function is defined inside another function, where an inner function, usually anonymous, is able to access variables from its enclosing function's scope, even after the outer function has finished executing or running, or has returned. The enclosing function scope means the area inside the outer function where its variables and functions are defined. When we talk about an inner function accessing the enclosing function scope, we mean that the inner function can use the variables and functions from the outer function. This creates a closed-over environment where the inner function remembers the state of the outer function at the time of its creation. In essence, a closure gives you the ability to create functions with memory of their originating environment. In simple words, when you create function inside a function, an outer function has returned inner function. It can still access variables from the outer function that contains it. And that closures remember the outer function scope even after creation time. Next, how closures work. When a function is defined, it has access to its own variables, and by that I mean variables defined inside the function. A global variables. Variables from the outer function scope, if the function is nested. To better understand the third point, a function scope refers to the area inside the function where its variables and parameters are defined and accessible. The inner function takes or accesses the variables it needs from the outer function's scope. This is what gives closures their power and flexibility. Let's break down this concept with some examples. Example 1, basic closure. Consider the following code. In this example, outer function defines a variable outer variable and a function inner function. Inner function can access outer variable because it is defined within the same scope, which means area inside a function. Outer function returns inner function, creating a closure. When my closure is called, it retains access to outer variable even though outer function has completed execution. Now in another example like this. In this example, inner function is a closure because it can access the x variable from the outer function scope, even after outer function has finished executing. Example 2, closure with private variables. Here's a more complex example. Closures are often used to create private variables, allowing controlled access through specific functions. In this example, createCounter initializes a count variable. It returns an object with methods increment, decrement, and getCount that can modify and access count. Count is private and cannot be accessed directly from outside createCounter, but the return methods form a closure that allows controlled access to count. Consider another alternative example like this. In this example, the counterfactory function returns an object with 3 methods: increment, decrement, and getCount. These methods have access to the count variable from the counterfactory scope, even after counterfactory has finished executing. Each call to counterfactory creates a new closure with its own count variable. This allows us to create multiple counters with different initial values. Example 3, closure with parameters. Closures can also capture parameters passed to the outer function. Here's how. In this example, greet is a function that takes a message parameter and returns another function that takes a name parameter. The inner function forms a closure that captures the message parameter from greet. When say hello and say goodbye are called, they remember the message passed to greet, and use it along with the name passed to the inner function. To help you better digest the concept of closures, here are 5 analogies. First, the backpack analogy. Imagine you are going on a hike and you pack a backpack with some essential items. During your hike, you can take out these items whenever you need them, regardless of where you are on the trail. Similarly, in JavaScript, a function packs its backpack with variables from its enclosing scope. Even when the function is executed outside of its original environment, it still has access to those variables. Here's a code example related to this analogy. In this analogy, supplies are the items in the backpack, and the function hiker can access these items even after leaving the create hiker starting point. Here's an alternative version of the backpack analogy. Imagine you're packing a backpack for a trip. The backpack represents the outer function, and the items you pack inside it represent the variables and inner functions. When you close the backpack and walk away, the backpack, outer function, has finished its job, but the items inside, the variables and inner functions, are still accessible to you. This is similar to how a closure closes over the variables it needs from the outer function, even after the outer function has finished executing. Second, the cookie jar analogy. Think of a child reaching into a cookie jar that is placed on a high shelf by a parent. The child remembers where the jar is and can grab cookies whenever they want. In JavaScript, the parent function sets up a cookie jar, variables, and the inner function, child, can access the jar even after the parent function is no longer in the picture. Third, the library card analogy. Imagine you have a library card that gives you access to the library's resources. Even if you leave the library, you can come back and use your card to check out books. Similarly, in JavaScript, an inner function gets a library card to access the outer function's variables and can use this access even after the outer function has returned. Fourth, the mailing package analogy. Suppose you need to mail a package to a friend. The process of packing the box and sealing it represents the outer function, and the contents of the box represent the variables and inner functions. Once the package is sealed, you can write the address on it and send it off. The address function, inner function, has access to the contents of the package, variables from the outer function, even though the packing process, outer function, is complete. Finally, the nested doll analogy. Imagine a set of Russian nesting dolls, where each doll contains a smaller doll inside it. The outer doll represents the outer function, and the inner dolls represent the variables and inner functions. When you open the outer doll, you can access the inner dolls, just like how a closure allows the inner function to access the variables from the outer function scope. Now, why are closures useful? Closures are incredibly useful in JavaScript for several reasons. 1. Data privacy and encapsulation. They allow you to create private variables that can't be accessed directly from outside the function, promoting data encapsulation. 2. Partial application and currying. Closures can be used to create functions that remember some of their arguments. 3. Functional programming. Closures are a key feature in functional programming, enabling higher-order functions, currying, and other advanced functional techniques. 4. Memoization. Closures can be used to cache the results of expensive function calls and return the cached result when the same inputs occur again. 5. Function factories. Closures can be used to generate functions with pre-configured settings, creating a sort of function factory. 6. Event handling and callbacks. They are often used in event handlers and callback functions, maintaining access to variables even when the context changes. 7. Event listeners. Closures are commonly used in event listeners to capture the state of variables at the time the listener is attached, and to maintain access to variables from the surrounding scope, even after the outer function has finished executing. This is particularly useful for creating more dynamic and flexible event handling. Now, the conclusion. Closures might seem complex at first, but with practice, they become a valuable tool in your JavaScript development arsenal. By understanding how inner functions access variables from outer scopes, you can create versatile and well-structured code. Closures are a powerful feature of JavaScript that enable functions to have private variables and retain access to their originating scope. By understanding and leveraging closures, you can write more modular, encapsulated, and expressive JavaScript code. Whether you're creating private variables, building higher-order functions, or handling events. So, the next time you encounter a function with a surprising memory, remember, it might just be a closure in play.